Welcome to all. In the previous video sessions, we have completed 1D bar elements. Today, we are moving to the next topic on the same module number 2, that is trusses. So, in this, we are going to study what is trusses, what are the types of trusses, so how to find the stresses and strains, so using a FEM method. So, let's see first introduction. So, what is trusses? A truss is a structural member made up of a number of bars are welded or riveted at joints used to take up the loads. So truss means it is not made up of one member, it is made up of like number of bars. So same type of only bars only it is made up of, but it is not more than one. They are connected together to make a rigid the structure. These bars are connected either it may be welded joint or it may be a riveted joint. So usual application is in building roads, bridges, transmission, mobile towers, all etc. So I can show you the figure. I can observe here. So here you can see this is a bridge, right? So this is a bridge, and you can what you can see these bars. So this is called a bars. So the number of bars together made a structure that is called a truss. So and one thing you can observe that the bars are not only one portion. So some bars are vertical in nature, some bars are inclined in nature, some bars are horizontal in nature. So when the more the number of bars you added, so therefore what happened? So it will be the more stiffer will be there, stiffness will be more. So stiffness is nothing but resistance to strength. What is the load come under this bridge? Not only to withstand that load, and also it should not be a deformed. Therefore more the bars if you added, more the stiffer will be there. So and also you can see that there is a roof structure. In roofs they are going to use this type of things, that is called a truss. That's also truss. And you can see in the mobile towers, right? Mobile towers as well as in power lines, this is called mobile towers, like a set of number of links they are going to use like this. So and also in your high tension wise poles they are going to use. So this is called a truss. So truss is made up of like bars, number of bars. That bars are placed in a different position like inclined, vertical, horizontal, so depending upon the structure design. More the bar if you add it, more the stiffness will be there. So therefore bars, trusses is made up of a number of bars. Now we'll see what are the characteristics of the bar. This is one of the important basic concept. Please keep in. A trusses element can resist only in axial force, either in tension or compression, only in axial. Because as I told, that is a characteristic of bar, right? What are the characteristic of bar is there? The same thing kind of trusses also it is applicable. Why? Because it is made up of number of bars. So the truss element can resist only in a axial. That means only along the length direction. So suppose if the bar is like this, it can take only in the axial direction along the longitudinal, either tension or it may be a compression. And also it will not able to carry any transverse loads. Keep this in mind. It will not take any bending loads or transverse load or bending moment. And also the loads and reactions are only applied at these joints. The load only at these joints. So this is called a characteristics of the truss. So what are the characteristics? It can take only the axial forces, either compression or tension in a longitudinal direction, and also it will not take any transverse loads or bending loads, and also the reactions or loads only applied at the joints, where and the joint, not at these points. Okay, only at these joints or fixed point they are going to apply the reaction as well as loads. So therefore this truss, so same characteristic of the kind of bars, because it made up of bars. Next one is what are the types of trusses are there? One is 2D, that is called plane truss. One is space truss, that is called 3D. So out of these two, we are only in the syllabus plane truss 2D. That means compared to length and width and thickness is very small will be there. So that is called as 2D truss. So the plane stress should satisfy this equation. So this is like a degree of freedom equation. It is you studied in a com, that is m is equal to 2j minus 3, where m is the what is the number of bars. If you are, suppose you have to calculate, means you can, using this equation you can calculate, that is 2j minus 3, that is number of joints. J is called number of joints. Let's just take an example of this. You can observe now, this is the one stress structure. So we can count the joints here, 1 2 3 4 and 5. Therefore what is the number of bars required for the 5 joints? 2j minus 5, that is 5 2 5 is 10, 10 minus 3 7. Totally there are 7 bars, 1 2 3 4 5 6 7. So therefore number of bars required for the joint 5 is 7. Like this we can calculate the number of bars for a 2D. That should be satisfy this equation. So before going to deal with the what is that stress to calculate equations as well as stiffness matrix, so let me see what are the assumptions they made in a entire trusses. So this also sometimes they will ask you in assumption, write the assumptions made in the trusses. So loads are applied only at the nodes. Loads are applied only at the nodes. That means where and a joint comes, that is the nodes. And the joints in trusses are assumed to be frictionless. That is very important. Sometimes they are going to use rivets also. So that cases what happened, what is the frictional contact between the contact surface between the rivets as well as bar surface, it should be a not friction, it is a frictionless joints. And also self weight, having a self weight, some bar will be neglected. We are not going to consider any self weight, its own weight. And also due to load applied, each of the bars either tensile or compression forces only. There is no transverse force. That is the characteristic of the trusses. These are the 4 assumptions they made. Load apply only at the node, joints are assumed to be frictionless, self weight are neglected, and due to applied can each of the truss either tensile in nature or compressive in nature. And one more time, so I think this also you heard in a mom, right? So determinate structure and indeterminate structure. In the same way, determinate trusses and indeterminate trusses. What is determinate trusses means? A determinate trusses is a one which can be completely analyzed by using static equilibrium equation conditions, that is summation of force equal to 0, summation of moment equal to 0. That means what are the unknowns, what is there, we are going to calculate using the equilibrium equation. There are two only equilibrium equations are present. One is summation of forces. In summation of forces again there are two types. Summation of vertical forces equal to 0, as well as summation of horizontal forces must be equal to 0, and also there is a summation of movement also equal to 0. So using these 3 equilibrium condition, if you can able to calculate the unknown, means that is called a statically determined structure, and with respect to trusses it is called statically determinate trusses. If intermediate trusses means intermediate stresses, one which cannot be completely analyzed by using only this. That means it is not enough to calculate the unknowns by using only this equilibrium condition. So therefore that is called indeterminate structure, or with respect to the trusses we can call as indeterminate trusses. So this make complications in nature. So usually mom approach will use only to calculate using for a determinate structure, that is only this equilibrium equation. For indeterminate, mom approaches make very difficult. Therefore, it is not feasibility to do that. But FEA method is a more versatile nature tool. FEA method can be used to both determinate as well as indeterminate type of stresses we can be analyzed. That is the most advantage of the FEA. Whereas in a mom approach is only determinate type of structure we can analyze. But in FEA both we can apply. So that is called statically determinate stresses, indeterminate stresses. Determinate means it can be solved, analyzed by using equilibrium conditions, that is summation of horizontal force equal to 0, vertical force equal to 0, as well as movement also equal to 0. Indeterminate means it is not enough to solve or analyze by only this equilibrium equation, that is called indeterminate stresses. So this is also one of the basic important concept. Okay, next one will come to the now. This is introduction. This is the introduction part. We'll see now come to the derivation part, that is derivation of transformation matrix for a plane trusses, or and also it is called a local and global coordinate of the trusses. So we are going to derive the transformation matrix for a 2D. I told you for syllabus we are dealing with only 2D trusses. So I think we have discussed these topics, what is local coordinate system, what is global coordinate system, in the beginning of the module 2 of this 1D bar, correct? So let me see that again here. Consider a 1D bar element showing with a 2 coordinate system. Where is the figure? Yeah, here you can see this is a bar we consider having a node of 2. So here x and y represent what? Global coordinate system. What is global system? We discussed global coordinate system which is represented with an measure the any dimension with respect to the origin, that is known as global coordinate system. And local coordinate system is what? With respect to the body we are going to measure the dimensions. So the dimension, that means coordinate system which is on the member. So the coordinate system which is with respect to the origin we called as global. With respect on the member itself it is called local coordinate system. There are 3 types we discussed: local, global, as well as one more is natural coordinate system. Natural coordinate, so which is used, coordinate system which is used in between the elements, that is called zeta. So one consider bar I have shown in the figure with 2 coordinate system. One is coordinate system that aligns with the length of the element, that means along the length. So that is x dash y dash we call this, that is called local coordinate system. In 1D bar element both local and coordinates are same. That is very important. You can see second point is very important. Sorry, one more we skipped. The other coordinate system that does not align with the element. That means you can see element is here, but we are taken with respect to origin, horizontal and vertical. That is global coordinate system, not along the element. That is global coordinate system, that is x comma y. This point is very important. In 1D bar element, both local and global coordinates are same, but in case of trusses element, local coordinates are different for each trusses. This is very important. Why? Because in bar means we are taken only one single bar, right? So therefore everywhere the local as well as global is same, but in case of trusses it is not same. Why? Because for each element it is different local coordinate. Why? Because you can see, so here orientation is different. Here oblique nature, inclined is there, here horizontal is there, some may be in vertical nature. Therefore it is differ in the orientation is differ in the local coordinate system. Therefore in case of truss local coordinates are different for each element. This is also one of the basic important concept. In case of 1D there is no thing, so either we consider horizontal or vertical bar, therefore local coordinate is same. But it is not like that. Here orientation is different. It is made up of not only one bar, it is made up of n number of bars. That is the reason. Now we need to derive the transformation matrix. For this let's consider the truss element having a node 1 and node 2 in local, and local coordinate is passing through the node 1 and node 2 represent x dash. That is next figure. You can see now they are considered one bar now. One bar. So now here node 1 and node 2 with respect to the along the bar they are considered the coordinate system, that is local coordinate system, that is called x dash. That is called x dash. Now due to load applied the truss attained a new position shown in figure, thereby locally the node 1 has a displacement of q1 dash and node 2 is a displacement of q2 dash. But in global coordinate each of the node have 2 degrees of freedom. What is that? Let me see. Due to load applied, the truss attain a new position of shown in figure. Thereby locally the node 1 has a displacement q1 dash and node 2 is a displacement q2 dash. You can see this is the initial position of the bar. When you apply the load, due to that load it moved to the next position. So therefore this is the red color what you can see, that is the next position of the bar after the applying the load, displacement of the bar after the apply the load. Due to that you can see q1, so now node 1 take in a displacement of q1 dash. Now node 1 here, now when the second portion it comes to here, therefore the local coordinate system, the local displacement become q1 dash. Here with respect to this origin it is q1 dash. Similarly node to move to the next portion, the local displacement become q2 dash. That is what he is saying. Truss certain position of shown figure, thereby locally node 1 as a displacement of q1 dash and node 2 as a local as q2 dash. But in global coordinate system, each of the node having 2 degree of freedom. Now with respect to the global, one is x along y. Not shown that. This is x, this is y. With respect to the global coordinate system, each node having 2 degree of freedom, one is only moving along x direction as well as y direction. So node 1 taking a x direction displacement is, according to the global system it is q1, according to the y direction it is q2. Similarly node 2 it is along the x direction is q3 and along y direction is q4. That is what he is saying in the next line. That is 2 degree, each node having 2 degree of freedom. X displacement of node 1 is q1, y displacement node 2 is q2. Similarly node 2 q3 q4. X displacement of q1 with respect to the global is q1, y direction is q2, and node 2 with respect to x direction is q3, and with respect to the y direction it is q4. Therefore the q1 dash and q2 are the local nodal displacement. q1, q2, q3, q4 are the global nodal displacement. So where q1 dash, q2 dash is called local nodal displacement. Local nodal, with respect to the local coordinate, it is displacement called as local nodal. With respect to the global coordinates, the corresponding displacement called as global nodal displacement, q1, q2, q3 and q4. Therefore I can now observe, now this bar it is certain orientation with respect to the horizontal, it is an angle theta. So let us call this is theta, and after the displacement this also, so you can draw the parallel lines. So with respect to this angle it is called as theta. Now here we need to apply the trigonometric rule. So let's consider this. You can see that there is a triangle here. I call this triangle as x, y, z, and I written separately here. Now let's made a right angle triangle here. Now according to this, what is the opposite adjacent, we'll see. Always I told theta opposite side is opposite, theta adjacent, this one is adjacent, and this one is become hypotenuse, or opposite to this one is side is hypotenuse. Now which is the rule I can apply? Now suppose if I apply the cos, this is we can called as this length they called as a, and this is they called as up to here distance is b. Therefore this is I called as a, and also this up to here the distance is called as q1. Therefore I know a, I know q1, I know hypotenuse, I know adjacent. Which rule I can apply? Cos theta. Cos theta is equal to adjacent by hypotenuse. Adjacent is a, hypotenuse q1. Therefore a become q1 into cos theta. I will repeat once again. When after the displacement with respect to theta, we are consider this bar with respect to horizontal, it is certain angle of theta. Now it form a triangle. That triangle is x, y, z. So this is horizontal, this is adjacent, hypotenuse, and this is opposite. So this distance we called as a, and this is we called as q1. Therefore adjacent by hypotenuse is a by q1. Similarly one more triangle we are considering, that is this small triangle. You can observe here this small triangle. Let's call this x dash, y dash and z dash, and this is also theta. At an angle theta will be there. That is I written here separately to understand purpose. Now you can observe what is the distance of this. We can call it as, according to the figure, b, and what is this distance we can call as q2. That is what I written here. Now let's see which is opposite. This is theta opposite, this is opposite, and this is adjacent. Remaining will become hypotenuse. Therefore I know opposite b, and this is I know hypotenuse q2. Opposite hypotenuse, the trigonometric relation is sin theta. Therefore opposite by hypotenuse, that is b by q2. Therefore b become q2 into sine theta. Therefore finally if we add it a plus b we can call it as q1 cos theta plus q2 sin theta. What is a plus b? We called as q1 dash, right? That is local nodal displacement. That is a plus b called q1 cos theta plus q2 sin theta. Similarly at node 2 what will become? q2 dash will become q3 cos theta plus q4 sin theta. Therefore compare this equation 1 and 2, we can write it in a matrix form. How we can write? q1 dash q2 dash column matrix and cos theta sin theta 0 0 0 0 cos theta sin theta q1 q2 q3 q4. If you multiply these two and you will get the same equations. Therefore this let called cos theta they consider as L and sin theta they called as M, where L and M are direction of cosine. Here onwards we are going to use this term L and M. It's called directions of cosines. Cos theta is called L, sin theta is called M. Therefore in place of cos theta and sin theta we can substitute this L, M. Therefore this what we can see, that is q1 dash q2 dash is equal to lm 0 0 0 0 lm q1 q2 q3 4. This one in general we can call it as q dash and matrix, and this is called as L matrix, and this is called q matrix, where q dash is called nodal displacement local coordinate, that is local nodal displacement matrix, and L is called transformation matrix. What is transformation matrix? Nothing but that is called lm 0 0 0 0 lm. And where is this one? It's called global nodal displacement. q1 dash q2 dash is the local nodal displacement, this is global nodal displacement. Therefore q dash is equal to L into q, where L is the transformation matrix. So this complete the derivation of, we derive the transportation matrix using this transformation matrix. Using this transformation matrix, next we are going to derive the stiffness matrix for trusses. We'll see in the next video.